Welcome to 3D Online Tuition. It is a three-dimensional e-learning method based on audio, visual, and event.
Yippee! Yay!
Chapter 5. The Air Around Us. 5.1. The Composition of Air. 5.2. The Properties of Oxygen and Carbon Dioxide. 5.3. Oxygen is needed for respiration. 5.4. Oxygen is needed for combustion. 5.5. Air pollution. 5.6. The importance of keeping the air clean. 5.1. The composition of air. 1. Atmosphere is a thick layer of air surrounded the Earth. 2. This thick layer of air is held around the Earth by the force of gravity. 3. Air is the mixture of gases, namely nitrogen, oxygen, carbon dioxide, and inert gases, for example argon, neon, helium, krypton and xenon. 4. Air also contains other components, for example water vapor, dust, and microorganisms. However, the quantities of these components are very small, and they vary from place to place, and from time to time. 5. Photosynthesis, respiration, and combustion change the percentage of oxygen and carbon dioxide in the air. 6. Humidity is used to measure the amount of water vapor in the air. Higher the humidity, means more water vapor found in the air. The percentage of gases in air. 1. 99% of air consists of nitrogen and oxygen. Nitrogen 78%. Oxygen 21%. Carbon dioxide 0.03%. Inert gases. Water vapor. Dust. Microorganisms 0.97%. 2. Air is a mixture because of A. The components of air can be easily separated by heating and fractional distillation. B. Each of the components of air maintain its original properties when separated. C. When air is prepared by mixing its components gases, no chemical reaction take place. D. The proportion of the components of air is not fixed, but varies from place to place, according to the condition of that place. The air in the forest area contains more oxygen than the air in an industrial area or city. The air in the tropical countries are more humid than the air in the countries with 4 seasons and desert. Experiment to investigate the percentage of oxygen in the air. Procedure.
1. Set up the apparatus as above, with the gas jar inverted over a candle, which is not lit yet. The water level marked, and the height of the air column in the gas jar, is measured, indicated as xcm. 2. The gas jar is removed to lit up the candle, and later put the gas jar inverted back over the burning candle. 3. Wait until the candle flame goes out. Mark the latest water level, and measure the air column left in the gas jar, indicated as ycm.
Result.
Height of air column, at the beginning of experiment, equals xcm, where x is equals to 20 centimeters. Height of air column, at the end of experiment, equals ycm, where y is equals to 16 centimeters. Percentage of oxygen in the air, equals 20 centimeters minus 16 centimeters. Divide by 20, and times 100%. Equals 20%.
Observation.
1. The candle flame, extinguished after some time, 2. The water level rises about 1/5, or 20%, of the air column in the gas jar.
Discussion.
1. The burning candle uses up the oxygen in the gas jar. 2. The increase of the water level in the gas jar is proportional to the amount of oxygen in the gas jar.
Conclusion.
1. Air contains of about 20% of oxygen.
Experiment to show that air contains water vapor. Procedure.
1. Set up the apparatus as above, with ice cubes put inside the test tube. 2. Close the test tube with stopper, and wipe the outer surface of test tube with a piece of tissue paper. 3. The test tube is left aside for a few minutes. 4. Let the liquid, formed on the outer surface of the test tube, drops into the beaker below. 5. Test the liquid collected in the beaker with a piece of dry cobalt chloride paper.
Observation.
1. Colorless liquid droplets are formed on the outer surface of the test tube. Some of the liquid is dropped into the beaker below. 2. The color of the dry cobalt chloride paper changed from blue to pink when tested with the liquid in the beaker.
Discussion.
1. When water vapor in the air comes into contact with the cool surface of the test tube, it condenses to form droplets of water on the outer surface of the test tube. When more droplets of water formed, it combines together and become heavy and drop into the beaker below. 2. The color changes of the dry cobalt chloride paper from blue to pink indicates the presence of water.
Conclusion.
1. Air contains water vapor.
Experiment to show that air contains microorganisms. Procedure.
1. Sterilize 2 petri dishes with boiling water for few minutes. 2. Some sterilized nutrient agar is poured into the 2 petri dishes. 3. One of the petri dish is covered, marked as X, while the other is without cover, marked as Y. 4. Both petri dishes are left untouched in the laboratory for 3 days. 5. After 3 days, examine the petri dish, X and Y, with a magnifying glass.
Observation.
1. The nutrient agar in petri dish X is clear. 2. There is some white thread-like growth, as well as black spots seen on the nutrient agar in petri dish Y.
Discussion.
1. Microorganisms in the air have settled on the nutrient agar in petri dish Y, and grown from there. 2. The airtight cover of petri dish X prevented microorganisms falls onto the nutrient agar.
Conclusion.
1. Air contains microorganisms.
Experiment to show that air contains dust particles. Procedure.
1. 3 microscope slides are cleaned, and an equal amount of petroleum jelly is spread over the 3 slides respectively. 2. Each slide is placed in 3 separate petri dishes. 3. First petri dish is placed in the laboratory, marked as X. Second petri dish is placed outside the laboratory, marked as Y. And third petri dish is covered, and put in the laboratory, marked as Z. Petri dish Z acts as control. 4. After 3 days, the petroleum jelly on all the 3 slides are examined with a magnifying glass.
Observation.
1. There are some amount of dust, seen on the petroleum jelly in Petri dish X and Y. Petroleum jelly on Petri dish Y has the most dust, as compared to Petri dish X. 2. There is no dust found on the petroleum jelly in Petri dish Z.
Discussion.
1. The dust particles in the air fell and stuck to the petroleum jelly on the slides. 2. There are more dust particle outside the laboratory than inside the laboratory.
Conclusion.
1. Air contains dust particles.
5.2. The properties of oxygen and carbon dioxide. 1. Oxygen and carbon dioxide are the two most important gases in the air for sustaining life on Earth. 2. Oxygen is the most vital element for most of the living things, including humans, on Earth, for the air to breathe and water to drink. 3. Carbon dioxide is required in the photosynthesis for plants to make own foods and consumed by all living things, and to produce oxygen as a byproduct. Carbon dioxide in the atmosphere, also important and capture heat, radiated from the Earth's surface. Properties of oxygen and carbon dioxide. State and room temperature. Oxygen. Gas. Carbon dioxide. Gas. Color. Oxygen. Colorless. Carbon dioxide. Colorless. Smell. Oxygen. Odorless. Carbon dioxide. Odorless. Solubility in water. Oxygen. Slightly soluble. Carbon dioxide. More soluble than oxygen. Density. Oxygen. Similar to air. Carbon dioxide. More heavy than air. Reaction to sodium hydroxide solution. Oxygen. Not soluble. Carbon dioxide. Very soluble. Reaction to glowing wooden splinter. Oxygen. Relights the glowing wooden splinter. Carbon dioxide. Extinguishes the glowing wooden splinter. Reaction to burning wooden splinter. Oxygen. Flame of the burning wooden splinter burns brighter. Carbon dioxide. Extinguishes the burning wooden splinter. Reaction to litmus paper. Oxygen. No reaction to blue or red litmus paper. Carbon dioxide. Blue litmus paper turned to red. Red litmus paper no change. Reaction to lime water. Oxygen. No reaction. Lime water remain clear. Carbon dioxide. Lime water become cloudy. Reaction to hydrogen carbonate indicator. Oxygen. No reaction. Carbon dioxide. Hydrogen carbonate indicator which is red turned to yellow. Experiments of oxygen and carbon dioxide. Experiments 1, Color and smell.
1. Examine the color of the gas in the test tube, against a piece of white paper as background. 2. Open the stopper, and smell the gas inside the test tube. Results. Oxygen. No color. No smell.
Conclusion. Oxygen is colorless and odorless.
Results. Carbon dioxide. No color. No smell.
Conclusion. Carbon dioxide is colorless and odorless. Experiments 2, Solubility in water.
1. Test tube filled with gas is inverted into a beaker of water. 2. Remove the stopper, and let the test tube shaken gently. 3. The level of water flow into the test tube is observed. Results. Oxygen. A little water enters the test tube.
Conclusion. Oxygen is dissolved slightly in water.
Results. Carbon dioxide. More water enters the test tube.
Conclusion. Carbon dioxide is dissolved more than oxygen in water. Alert. Oxygen dissolved in water allows fishes and other underwater living things to breathe. Alert. Carbon dioxide dissolved in the water to form carbonic acid, which makes normal rain slightly acidic. Experiments 3. Reaction with sodium hydroxide.
1. Test tube filled with gas is inverted into a beaker of sodium hydroxide solution. 2. Remove the stopper and let the test tube shaken gently. 3. The level of sodium hydroxide flow into the test tube is observed. Result. Oxygen. No sodium hydroxide solution enters the test tube.
Conclusion. Oxygen is not soluble in sodium hydroxide solution.
Result. Carbon dioxide. Sodium hydroxide solution rises rapidly in the test tube.
Conclusion. Carbon dioxide is very soluble in sodium hydroxide solution. Experiment 4A. Reaction on glowing wooden splinter.
1. Stand by a glowing wooden splinter. 2. Remove the stopper of the test tube and put the glowing wooden splinter inside the test tube. Result. Oxygen. The glowing wooden splinter lights up.
Conclusion. Oxygen relights a glowing wooden splinter.
Result. Carbon dioxide. The glowing wooden splinter is extinguished.
Conclusion. Carbon dioxide extinguishes the glowing wooden splinter. Experiment 4B. Reaction on burning wooden splinter.
1. Stand by a burning wooden splinter. 2. Remove the stopper of the test tube and put the burning wooden splinter inside the test tube. Result. Oxygen. The flame of the burning wooden splinter burns brighter.
Conclusion. Oxygen help in burning wooden splinter.
Result. Carbon dioxide. The flame of the burning wooden splinter is extinguished.
Conclusion. Carbon dioxide extinguishes the burning wooden splinter. Alert. Oxygen supports combustion, but does not burn. Alert. Carbon dioxide does not support combustion, and does not burn. Experiment 5. Reaction on litmus paper.
1. Remove the stopper of the test tube. Put in each a piece of moist red litmus paper and blue litmus paper. 2. Close back the stopper and observe the color changes of red litmus paper and blue litmus paper. Result. Oxygen. No color changes of red litmus paper or blue litmus paper.
Conclusion. Oxygen does not react on litmus papers. Oxygen is neutral.
Result. Carbon dioxide. The blue litmus paper turns to red. The red litmus paper remains unchanged.
Conclusion. Carbon dioxide turns blue litmus paper to red. Carbon dioxide is acidic. Experiment 6. Reaction on lime water.
1. Remove the stopper of the test tube. Pour in small amount of lime water. 2. Close back the stopper and shake the test tube gently. Result. Oxygen. The lime water remains clear.
Conclusion. Oxygen does not react on lime water.
Result. Carbon dioxide. The lime water becomes cloudy.
Conclusion. Carbon dioxide reacts with lime water to form calcium carbonate, which looks cloudy. Experiment 7. Reaction on hydrogen carbonate indicator.
1. Remove the stopper of the test tube. Pour in small amount of hydrogen carbonate indicator. 2. Close back the stopper, and shake the test tube gently. 3. The color of the hydrogen carbonate indicator is observed. Result. Oxygen. The hydrogen carbonate indicator remains no change.
Conclusion. Oxygen does not react on hydrogen carbonate indicator. Oxygen is a neutral gas.
Result. Carbon dioxide. The hydrogen carbonate indicator, which is red, turns to yellow.
Conclusion. Carbon dioxide turns hydrogen carbonate indicator, which is red, to yellow. Carbon dioxide is an acidic gas. Standard test for oxygen and carbon dioxide. Oxygen. With glowing splinter. 1. When a glowing splinter is put into a test tube filled with oxygen gas, the glowing splinter will light up. 2. This is because oxygen gas supports combustion. Carbon dioxide. With lime water. 1. When lime water is poured into a test tube filled with carbon dioxide, the lime water becomes cloudy. 2. This is because carbon dioxide reacts with lime water to form calcium carbonate, which is insoluble in water. 5.3. Oxygen is needed for respiration. 1. Breathing is a movement of air, in and out of the lungs. 2. The exchange of gases takes place in the lung, as we breathe in and breathe out. Breathing is controlled by the movement of the diaphragm and intercostal muscles.
Inhale is the air we breathe in. Exhale is the air we breathe out.
3. Respiration is the chemical process where energy is released from the breaking down of foods in living organisms. 4. Respiration requires oxygen to oxidize the glucose in the cells to release energy. 5. Carbon dioxide and water vapor are the waste products of respiration process. The difference between inhaled air and exhaled air. Inhaled air contains more oxygen than exhaled air.
1. The composition of inhaled air and exhaled air are different, because oxygen is used, and carbon dioxide is released during respiration. 2. Exhaled air can be collected as below method.
Result.
Candle A burns longer than candle B.
Conclusion.
Inhaled air contains more oxygen than exhaled air.
Exhaled air contains more carbon dioxide than inhaled air.
Result. Lime water remains clear. Result: lime water becomes cloudy.
Conclusion.
Exhaled air contains more carbon dioxide than inhaled air.
Exhaled air contains more water vapor than inhaled air.
Result: mirror remains clean. Result: mirror has tiny drops of water.
Conclusion.
Exhaled air contains more water vapor than inhaled air.
Nitrogen. Inhale air has 78%. Exhale air remains 78%. This is because nitrogen did not involve in respiration. Oxygen. Inhale air has 21%. Exhale air dropped to 16%. This is because oxygen used in respiration. Carbon dioxide. Inhale air, only 0.03%. Exhale air, increased to 4%. This is because carbon dioxide produced in respiration as waste products. Inert gases. Inhale air, has 0.97%. Exhale air, remains 0.97%. This is because inert gas is not involved in respiration. Water vapor. Inhale air, varies, depends on location. Exhale air, saturated. This is because water produced in respiration as waste products. Temperature. Inhale air, usually lower than 37 degrees Celsius. Exhale air, 37 degrees Celsius, similar to body temperature. This is because heat produced in respiration as waste products. Experiment to show that living things use oxygen during respiration. Hypothesis.
Living things uses oxygen during respiration process.
Variables.
Manipulated. The presence or absence of living things in the boiling tube. Responding. Position of the indicator, the drop of red ink, and volume of air. Constant. Air in the boiling tube, and the size of the boiling tube.
Test A. Is a boiling tube with a glass tube. A cotton soaked with sodium hydroxide solution placed inside the tube. A wire gauze to prevent test subject come too close to the cotton. And a drop of red ink used as an indicator. In the test A, the test subject is a live cockroach. In the test B, the test subject is some germinating green beans. In the test C, there is no test subject. Test C is use a control. Procedure.
1. Set up test A, B, and C. 2. The initial position of the indicator red ink of each test is marked. 3. Keep all 3 tests in a horizontal position, in a dark cupboard, for several hours. 4. The final position of the indicator red ink of 3 tests are marked at the end of the experiment.
Observation.
1. The position of the indicator red ink of test A and B had moved toward the boiling tube. 2. The indication red ink in test C remained at the same position.
Discussion.
1. The cockroach and germinating green beans used oxygen in the boiling tube during respiration process. The carbon dioxide that they breathe out is absorbed by the sodium hydroxide solution in the cotton. 2. The content of oxygen in test A and B becomes lower, and makes the indicator red ink move toward the boiling tube.
Conclusion.
1. Living things used oxygen during respiration. Hypothesis accepted.
Experiment to show that living things give out carbon dioxide during respiration. Hypothesis.
Living things released carbon dioxide during respiration process.
Variables.
Manipulated. The presence or absence of living things in the boiling tube. Responding. Color changes of hydrogen carbonate indicator. Constant. Air in boiling tube, and the volume of indicator used.
Test D. Is a boiling tube filled with some hydrogen carbonate indicator, which is red in color. There is a wire gauze in the middle of the tube, to prevent test subject fall into the hydrogen carbonate indicator. In this test, the test subject is a live cockroach. In the test E, the test subject is some germinating green beans. And, in the test F, there is no test subject. Test F acts as the control. Procedure.
1. Set up test D, E and F. 2. The color of the hydrogen carbonate indicator of the tests are recorded. 3. Keep all 3 tests in a vertical position in a dark cupboard for several hours. 4. The boiling tubes are slowly shaken after a few hours, and the color changes of the indicator of each test is observed.
Observation.
1. The hydrogen carbonate indicator in test D and E change from red to yellow. 2. The indicator in test F does not change color.
Discussion.
1. The cockroach in germinating green beans released carbon dioxide during respiration process. The carbon dioxide that they breathe out changed the color of the hydrogen carbonate indicator from red to yellow.
Conclusion.
1. Living things released carbon dioxide during respiration. Hypothesis accepted.
5.4. Oxygen is needed for combustion. 1. Combustion is a chemical process, in which a substance, called fuel, reacts rapidly with oxygen, to produce heat, and light. 2. Examples of combustion are A. A burning candle flame. B. An explosion of mixture of petroleum gas and air. 3. Substances that can burn easily, include A. Organic substances, such as alcohol, ether, and xylene. B. Carbon, such as charcoal and coal. C. Hydrocarbon, such as petrol, diesel, oil, kerosene, candles, and butane. Condition for combustion. Combustion can only occurs when 3 conditions are satisfied. That is, the presence of fuel, which is the substances that can burn. The presence of oxygen. The presence of heat, to warm the fuel, until it reaches ignition temperature. 4. Combustion only occurs when the fuel is heated until it reaches its ignition temperature. Different fuels have different ignition temperature. For example, the ignition temperature of kerosene is 225 degrees Celsius. 5. The product of combustion depend on the type of fuel used. Carbon-based fuel, such as charcoal and coal, etc. Oxygen. With carbon. Combustion. Carbon dioxide. And energy. Hydrocarbon-based fuel, such as petrol, diesel and kerosene, etc. Oxygen. With hydrocarbon. Combustion. Carbon dioxide. And water. and energy. Experiment to show that oxygen is needed for combustion. Hypothesis.
Oxygen is needed for combustion.
Variables.
Manipulated. The burning of candles. Responding. Volume of gas left in the gas jar. Constant. The initial volume of air in the gas jar.
Procedure.
1. Set up the test A and B, as above, side by side. 2. The candle in test A is placed outside the inverted gas jar. The candle in test B is placed inside the inverted gas jar. 3. Mark the water level for both gas jar. 4. Observe both candles. Stop the experiment when any of the candle flame goes out. Mark the new water level for both gas jar.
Observation.
1. The candle flame in test B went out first. The candle in test A remains burned. 2. The water level of gas jar in test A did not change. The water level in test B went up about 1/5, or 20% of the gas jar.
Discussion.
1. The candle in test A remains burned because it has unlimited supply of oxygen from the surrounding. 2. The candle in test B has limited supply of oxygen inside the gas jar. Once the supply of oxygen used up, the candle flame went out. The water level also went up, till around 20% of the gas jar, in accordance with the 21% of the oxygen in the air.
Conclusion.
1. Oxygen is needed for combustion.
Experiment to study the effect of the size of the container on the length of the candle burning. Hypothesis.
The larger the container, the longer a candle burns in it.
Variables.
Manipulated. Size of containers. Responding. Time for candle to burn. Constant. Size and type of candles used.
Procedure.
1. Set up the test C and D, as above side by side. 2. Lit up the candles. Cover the candle in test C with a container of 500 milliliters. Cover the candle in test D with a container of 1000 milliliters. 3. Record the burning time of both candles.
Observation.
1. The candle flame in test C went out first. The candle in test D remains burns about twice longer than candle in test C.
Discussion.
1. The larger container contains more air and oxygen. Therefore, the candle in the larger container burns longer.
Conclusion.
1. The larger the container, the longer a candle burns in it.
Experiment to determine the products of combustion of charcoal, carbon-based. Procedure.
1. Place a small piece of charcoal in a gas jar spoon, and lit using a Bunsen burner. 2. After the charcoal starting to burn, lower the gas jar spoon into a gas jar filled with some lime water at the bottom of the gas jar. 3. Wait until the burning charcoal extinguished. Feels the temperature of the outer surface of the gas jar with hand. 4. Shake the gas jar slowly, to observe the color changes to the lime water. 5. Use a piece of dry cobalt chloride paper to wipe the residue, if any, left inside the inner surface of the gas jar, to test for the presence of water.
Observation.
1. The outer surface of the gas jar felt hot. 2. The lime water in the gas jar became cloudy. 3. The residue from the inner surface of the gas jar did not make any color changes to the cobalt chloride paper.
Discussion.
1. Energy in the form of heat, released from the combustion of charcoal. 2. Carbon dioxide present in the gas jar, and make the lime water became cloudy. 3. Charcoal consists of carbon only.
Conclusion.
1. Carbon dioxide, and energy, heat, are products of the combustion of carbon-based fuel like charcoal. Oxygen plus carbon. Combustion. Carbon dioxide plus energy.
Experiment to determine the products of combustion of candle, hydrocarbon-based. Procedure.
1. Set up apparatus, like above. 2. Lit up the candle. Let the gases from the burning candle sucks through the U-tube and the test tube by a filter pump. 3. Feels the temperature of the outer surface of the funnel with hand. 4. Monitor the color changes of the lime water in the test tube. 5. There are some colorless liquid accumulated on the bottom of the U-tube. Test this liquid, at the end of the experiment, with a piece of dry cobalt chloride paper, to test for the presence of water.
Observation.
1. The funnel felt hot. 2. The lime water in the test tube became cloudy. 3. The colorless liquid turned the cobalt chloride paper from blue to pink.
Discussion.
1. Candle is a hydrocarbon-based fuel. 2. Carbon dioxide released from the burning candle passed through the lime water and the test tube, and turned it to cloudy. 3. The hot water vapor from the burning candle cooled by the cool water to become liquid water. The liquid water tested positively by the cobalt chloride paper.
Conclusion.
1. Water, carbon dioxide, and energy, heat, are products of the combustion of hydrocarbon-based fuel, like candle. Oxygen plus hydrocarbon. Combustion. Carbon dioxide plus water plus energy.
5.5. Air pollution. 1. Air pollution is a condition where the amount of harmful substances, pollutants, in the air is at a high level. 2. Air pollutants include harmful solid particles and toxic gases. They were produced by the activities of humans. 3. Air pollutants such as dust, carbon dioxide, pesticides, smoke, chemical waste, etc., decreases the air quality, and threaten the health of the living things. Type of pollutant: smoke, soot, haze. Sources: burning of waste and fuels by humans, factories, power stations, and vehicles. Forest fires. Cigarette smoke. Effects: polluted the environment. Slow down the process of photosynthesis in plant, by reducing the sunlight reaching the plant leaves. Damage the lungs, and other respiratory system. Damage the liver, and may cause cancer. Type of pollutant: dust. Sources: quarries, steel factories, cement factories, asbestos factories and timber factories. Exposed land. Effects: polluted the environment. Slow down the process of photosynthesis in plants, when it falling down on the surface of the plant leaves. Damage the lungs, and other respiratory system. May cause lung diseases. Type of pollutant: carbon dioxide. Sources: burning of fuel in factories, power plant, and vehicles. Burning of rubbish. Effects: causes the greenhouse effect, where the temperature of the Earth increases. When the temperature of the Earth continues rises, it will melt the ice caps in the North Pole and South Pole, and causes the sea levels rises, and destroy the coastal areas. Type of pollutant: sulfur dioxide. Sources: burning of fuel in factories, power plants, and vehicles. Burning of polymer and plastic. Effects: irritates our eyes, and causes breathing difficulties. Acid rain that can causes damages to animals and vegetation. Destroy slowly the buildings and bridges. Type of pollutant: carbon monoxide. Sources: burning of hydrocarbon fuel in factories and power plants. Exhaust gases from motor vehicles. Cigarette smoke. Effects: when inhaled in a small amounts, it absorbed into the blood and prevent the blood from absorbing oxygen, thus causes dizziness and headaches, or even brain damage. Causes death when inhaled in a large amount. Type of pollutant: oxide of nitrogen. Sources: burning of hydrocarbon fuel in factories and power plants. Exhaust gases from motor vehicles. Effects: as greenhouse gases that contributed to the greenhouse effect. Cause acid rain. Damage the lungs and other respiratory system. May causes lung and other respiratory system diseases. Type of pollutant: lead particles. Sources: vehicle exhaust fumes. Effects: damage to the nervous system. Causes brain damage in children. Causes lead poisoning. Type of pollutant: chlorofluorocarbons, CFC. Sources: aerosol cans, refrigerators and air conditioners. Electronics and semiconductor factories. Effects: as greenhouse gases that contributed to the greenhouse effect. Destroy the Earth's ozone layer that protected us from the harmful ultraviolet radiation, UVR, from the sun. Excessive exposure to ultraviolet radiation can cause diseases like skin cancer and eye cataracts. Type of pollutant: nicotine and tobacco tar. Sources: cigarette smoke. Effects: nicotine discolors teeth, cause bronchitis. It also causes lung and throat cancer. Tobacco tar blackens and damages the lungs and the nervous system. It also causes heart disease and lung cancer. Type of pollutant: chemicals such as pesticides and DDT. Sources: DDT spraying to kill mosquitoes. Pesticide spraying to kill unwanted inserts in the agriculture industry. Effects: causes disabilities in fetuses during pregnancies. Causes food poisoning. Damage the liver. Steps to prevent and control air pollution. Role of society. Avoid open burning of rubbish. Recycle paper, cans, bottles to reduce waste and rubbish. Use CFC-free products. Use unleaded petrol and diesel. Use more public transport instead of own vehicle. Science and technology. Use catalytic converters that can convert harmful exhaust fumes from vehicles into carbon dioxide, nitrogen and water. Electric car with zero emission of harmful gases. Power plant using renewable resources like solar, wind, and geothermal energy. Replace coal-fired power plant with natural gas, or liquid petroleum gas, LPG, fired plant. Smart farming, and precision agriculture to prevent waste in land, water, fertilizers, and pollution in the agriculture industry. Law enforcement. Legal action against those who broke the environmental law. Regular inspection and check by the authorities. 5.6. The importance of keeping the air clean. 1. A good quality environment provides all the basic needs of life, such as fresh air, clean water, sufficient sources of energy, and abundant foods. 2.
A clean environment is important for the survival of human beings and other living organisms. Ways and habits to keep air clean. Recycling papers, cans and bottles to reduce waste and rubbish. No open burning of rubbish. Use only CFC-free products. Use unleaded petrol to reduce amount of lead particles released from the vehicle's exhaust. Encourage to use public transport such as buses and trains. Promote carpooling to help to reduce the numbers of vehicles on the road.
3.
While on racing to achieve a better social economic growth and development, we must balance it with an efficient environment control and management.
The 3 pillars of sustainability: social, community development, workplace health and safety, education, employment, culture development; economic, manufacturing, transportation, energy generation, job creation, business development; environment, air pollution control, noise pollution control, renewable energies, agricultural and foods production, green transportation.
Happy Learning